Okay, can you see my charts okay?
Yes.
Okay, good. Okay. So I'll get started. Hello, everyone. This is Lorraine Herger. This year I have the privilege of being the chairperson of the Women in Services Computing Symposium. Thank you to everyone who's contributed so far and also to everyone who's attending. So I'm just going to go through a few starter charts. So this is, I'll go through the agenda just so everybody knows. So I'm going to make a few remarks here in the next, like, say, 7 minutes. And the format will be the following. Each keynote speaker in this first session in particular will give a short summary of her technical talk, and then it will be followed by Q&A. And over here, I've listed the speaker's name and the session chair. And we have 3 very interesting talks in different areas of technology. Okay. And then in the second session, we have, this is our professional and organizational talks. So the first talk is going to be on the road to a transformation that Huda Chikiri has recorded for us. Now, unfortunately, she can't be here, so we will view a part of her video, and Kautar is going to be the session chair for that one. And then the last 2 talks are about organizations that have provided a lot of support in terms of technical support, mentoring, and networking for women around the world, really. And that's WORMS, Informs, WORMS, and the Society of Women Engineers. And we have 2 of the representatives from those organizations joining us to talk about these organizations. And again, we'll follow that same process. The speaker will give a short summary, and then it'll be followed by a Q&A. So between the 2 sessions, there'll be a 10-minute break, and then we'll reconvene. So we'll reconvene for the second session. And then the end of the second session, we will have the awarding of the 12 WISC scholarships, and that session chair is Shubi Ashtani. So that's the entire 2 sessions, and we'll try to keep on pace as well. So the first thing I would like to do is I would like to say congratulations to Kautar, who's online with us, Dr. Kautar El-Magraoui, who's a principal research staff member at AI Engineering and IBM Research in Yorktown Heights. And Kautar was awarded the Women in Engineering Computing Award for her work in the development of infrastructure for next generation AI hardware, and her leadership and contributions across a wide variety of organizations, but in particular to the Arab Women in Computing organization. So congratulations, Kautar, well deserved, well earned. I'm very happy to announce this. And now I am going to turn it over to Kautar, and I'd like her to give a short acceptance talk for the award. Okay, so I'll stop sharing and turn it over to Kautar.
Thank you very much, Lorraine. I'm extremely humbled and honored to be receiving such an important award, the IEEE TCSVC Women in Services Computing Award. I'm earnestly grateful for the recognition I have received for my work, because I'm very sure that every other nominee for this award was as capable, if not more, of winning this award. As I reflect on my career, it took a lot of sweat and tears to get where I am today. Lots of challenges along the way, but each one of them has only strengthened me to make me the person who I am today. A thorough and responsible scientist who knows exactly what she wants, and someone who sets her eyes on a goal and does not lose sight of it unless it is achieved. I carried the dream of my mother, who did not have the means to pursue a higher degree, as she had to make money at an early age to support a family of 8 kids. My mother has been my biggest inspiration, and she instilled in me the love of science and math at an early age. Her dream was to become a scientist. The work I do in the AI Hardware Center is foundational, as it is shaping the future of AI hardware acceleration. The AI Hardware Center is a global research hub to develop next generation AI hardware for faster and energy efficient AI. I'm thankful for the opportunity to work in such an important mission, hand in hand with an amazing team of world-class scientists. I would like to especially thank my colleague, Lorraine Herger, who is chairing this session, and with whom I share the responsibility of leading the AI Hardware Center testbed project. Lorraine has been such a wonderful collaborator with great vision, work ethics, and thought leadership. I have learned a lot from you, Lorraine. Thank you. Together, we're creating key consumable services for next generation AI hardware. I'm very passionate also about women empowerment, especially in the area of computing. I love to give back to all women in computing. I serve as the Global Vice Chair for Arab Women in Computing nonprofit organization, to whom I have been providing critical leadership since its inception in 2012. I have worked tirelessly to raise funds to allow students from poor and war-torn countries to attend conferences and obtain scholarships and establish partnerships with various international organizations such as ACM, IEEE, and Anita Borg Institute. Today, Arab Women in Computing has 19 active chapters across the world and more than 6,000 members, and it is growing rapidly. Working closely with a great team of passionate professional women spanning academia and industry, such as Professor Sana Odeh from NYU and Professor Manar Abu Talib from Sharjah University from the UAE, and Susan Malaika from IBM, and Bushra Boqatta from Amazon, and many others. We work on inspiring women in the MENA region and beyond, creating collaborative projects, seeking and identifying scholarships for women who need support, and bringing women in academia, startups, industry, and students together. I sincerely thank my husband, my IBM colleagues, and my Arab Week collaborators who have helped me reach a stage where I can proudly hold up this award as a mark of my achievement. Winning this award would not have been possible without the inspiration I have received from all of them, for whom I have the deepest respect and for whom I have derived the strength to challenge myself and perform better at each stage. Thank you.
Thank you, Kawtar. So we have a little virtual clapping.
How do I?
Very nice. Thank you. I love those little virtual claps.
Yeah, but you should make a noise though, right? Otherwise you don't.
Yeah, I know.
Whether it's clapping or praying, I don't know.
Well, I think it's clapping. It looks like clapping.
It is clapping, but it,
Yeah.
yeah. Oh, thumbs up is good.
Yeah.
Yeah,
Thank you very much.
You're welcome.
that was wonderful. Yeah, very motivating.
Thank you, Dr. Bhavani.
So let's see, I'm going to just have a couple more things to cover, and then we'll go on to the first keynote. So again, congratulations, Kawtar. Now, I also have one award here, which I can pretty sure is a surprise. And this is congratulations and thank you. And this is an award, a team award to Mari Abe, who's one of the 2021 program chairs, and to her sister, UK Abe,
Oh,
who actually designed our logo, which I have in the center here. And we would like to honor both of them with this team award. So thank you, Mari.
Thank you, Mary, and thank you, Yuki.
is
Great work.
Yuki's there or she's not? Is she there?
No, I don't think so, right? Your sister's not here, Mari, right? You're on mute, Mari.
That's okay.
You're on mute, Mari.
Oh,
There we go.
I'm talking myself, sorry. I'm very happy to hear this news because my sister actually, it's completely voluntary work.
Mhm.
And she's very happy to create this logo.
Mhm.
And she's struggling with creating some curve, change the color, and created a lot of versions of this logo
Mm.
in a month, I suppose.
Mhm.
So I think she will be very happy to hear this news. Thank you.
Okay. I will send you I have a PDF that you can print out. It's a certificate and for you and your sister as well. Okay, so let's see. I am not going to announce the scholarships here. This is our first 2021 scholarship awards. We, thanks to the generosity of the conference, of the Congress, we're able to award 12 scholarships, and Shubi will be covering that in the last session of our second session today. So I did want to say that this is, really outstanding, and the recipients are quite a remarkable bunch of women. And finally, just thank you to everyone, our honorary general chairs, Rong is here, the advisory committee, the program chairs, and the program committee. It was a great team effort, so thank you to everyone. Okay, so now we'll go back, we can start the sessions with the first keynote. So I'm going to turn it back over to Kautar. So I'll stop sharing.
Thank you, Lorraine. Yeah, let me share my screen. Can you see my screen?
yes.
Yes.
Okay, great. So yes, in this session, we're very honored to have Professor Yutong Lu, who's professor of computer science from Sun Yat-sen University in China. And she'll be talking to us about a capable platform for convergence for HPC and AI. Just a brief history, biography of Professor Yutong Lu. She's a professor at Sun Yat-sen University. I hope I said it correctly. And the director of the National Supercomputing Center in Guangzhou, China. She is a member of the Chinese National Key R&D Project, the HPC Special Expert Committee, and the leader of the innovation team of Zhujiang Talent Program. She has extensive research and development experience that has spanned several generations of domestic supercomputers in China. She is also the deputy chief designer of the Dianhe 2 system, the only system that held the #1 position 6 times on the top 500, which is a very prestigious award. She has won the special prize and the first prize from the National Science and Technology Progress Awards in 2014 and 2009, and published more than 100 papers and 30 patents. She is devoted currently to the research and implementation of system and application platforms from the conversions for HPC, big data, and AI in supercomputing centers. And just a little bit about, the talk. So in this talk, she'll be covering about the future supercomputing system design, as it is facing many challenges, such as, architecture, system software, application environment, etc. And in her talk, she will analyze HPC, big data, and AI applications use cases and uses models in current supercomputing centers. I'm talking about the design of this platform that's capable of converging these key, platforms, HPC, big data, and AI. So without further ado, I would like to give the floor to Professor Yutong Lu.
Hi, thank you. Thank you, Kautar, for the introduction. Because it's my first time to join the women in the service computing this event. So it's my pleasure and my honor. And the procedure of that, should I share my slides or I just talk about that? Can you hear me?
You
Should
can
I
show you, yeah, you can show your slides.
Okay.
You can, like, maybe for like 10, 15 minutes.
Oh,
Okay.
so, okay. Let me, can you see the slide now?
Yes.
Okay. Thank you. It's my pleasure to meet you all online. You know, the supercomputing technology has been developed very faster in recent years, especially in past 20 decades. So it impact the science and the society deeply and broadly. So the computing-driven and data-driven scientific discovery has become a necessary research approach in the global environment, life science, nanomaterials, high energy physicals, and many other fields. So in my talk, so I talk about and discuss with you about some, now some new trends. So the rapidly increasing the computing requirement from economic and social development also call for the power of the next generation supercomputing systems. And in my slides, I talk about summarize some status, give you a brief overview of the supercomputing status in China. So some advance in the hardware, software, and application environment, and also the the different supercomputer centers in China. And this is our center. So we have the Tianhe 2, the supercomputer, the 6 times #1 supercomputer in the top 500, and now least in the number 6. I think the most important thing I want to mention is that nowadays in China, in supercomputer centers, for example, in supercomputer center in Guangzhou, not only service for the traditional high performance computing users, such as the climate, the energy, and the chemical and physics, something traditional HPC service, but also something like the biomedicine, the big data application, the AI application, and the smart city. So it's a clearly trend for the supercomputer center. We need to tackle the HPC and big data and AI convergence requirements. So, and we also facing many challenges for the next generation supercomputer. So it's focused on the power consumption, the application performance, programmability, and also resilience. The scale of the next generation supercomputer will be very large. And another, so we are focused on the new architecture, so especially the heterogeneous architecture of the next generation supercomputer center. And also we're facing the memory gap between the memory performance and the CPU and processor performance. And also the large scale interconnection and the whole system resilience technology and the tool. So we focus on the whole system balance, the communication, the computing, and the I/O capability, and the whole hardware and the software core design to implement the whole system, the balance. So for us, when we design and develop the new generation supercomputer center, we always do the thing is trade-off. So trade-off on the hardware, software, and the application. So this is a trend. So actually, the essential character of HPC, big data, and AI somehow is different. You know, the HPC is focused on the simulation, and big data focus on the to get the insight of the get the insight of the big data and the artificial intelligence actually to help people to make decision. So, but it's all driven by computing and fueled by data. So we focus on the variation, performance, productivity, and the adaptation and the evolution of the whole platform, not only the hardware platform, but also the software platform. So we are facing hybrid application cases and many types of architecture, and we will deal to the mass data and the data movement. So we need the platform. So in my slides, I compare with the feature of the application come from the HPC, big data, and AI. Compare many with the computation, communication, and storage model from the typical, the three kinds of typical applications. So they have some, the common points, but also have some difference. So we, and another thing we talk about is, the requirement come from the, I mentioned before, come from the convergence. So in one hand, it's driven by applications. So, HPC, traditional HPC application also have a large amount data analytic requirements. So we call it HPDA, so high performance data analytic for the scientific discovery. And also for the HPC plus AI, that means many the traditional HPC way to deal with the scientific discovery. We use simulation, but now we use simulation plus deep learning. So the deep learning fueling science, something like that. So we need to deal with large model and the training and AI model. So to improve the traditional model. So from the requirement part, there are many, the power we need to high performance HPC system to support that requirements. And another thing is driven by algorithm. So you can see now in the both in HPC, big data and AI, the applications, if we analyze the core, the key algorithms of the AI, deep learning, so we can see that there are many traditional algorithms, classical HPC algorithms, shared by big data and AI. So we can use the mutual algorithm from HPC. And let's see this. We have already have many mass library we could use to contribute to the improve the AI and big data applications. So last thing I'll talk about how to establish the capable platform over the exist supercomputer. And I give some example and talk about some experience and practice we are doing now. So I think that is the point. So we try to establish a platform for faster generation and developed application platform. So that's a concept we designed and implement to focus on the application. So we think of a research study, technical study should comes from the practice and goes to the practice. So we try to use and join force to develop the capable platform for the domain application. So we have our own convergence-oriented software stack. So we call it Starlight. So we have a software stack to support the convergence-oriented data management and scheduling and container-based OS and to support the convergence application. So that's some detail about that. And I also give you some application cases that we use this platform to support. The real application come from the weather forecast system. They need a simulation, parse the deep learning to refine the whole model and also the visualization. So this is the whole application workload to running on the supercomputer to combine the HPC big data and deep learning to get more efficient results. And also another application is on the virtual drug screen platform. And also some applications we used on the traffic video processing platform for support smart city. So, so we are clearly seeing that HPC are facing new needs, and also HPC can fit the new needs. So also the trend of the future HPC is heterogeneous on the architecture level and as well as the software level. So the software stack, we try to establish a platform, capable platform, to to give a user easy used and domain-specific application platform. So this is we proposed a paradigm. We call it 4C: composable, configurable, and controllable and capable. And we need 3 model. So we need to modeling the computation and the modeling data and the modeling pattern also. So this is a summary, is that we want to make HPC more smart. So we need core design in different level. So from core design of the compute and storage architecture. So data is very important. It's the key thing. And also the core design of software and hardware and multiple application models. And we also, from the the local area network, as well as the wide area network applications, we have the users come from all over the China and in different part, and they have different requirements. And also the people is a key point. So the collaboration of the interdisciplinary talents. So I want to use that to give to the end. It's we want to come from the gent of computation to the gent of intelligence. So that's all for my very short and brief talk about this topic. Thank you. And any question and comment?
Thank you so much for this great talk. Very, very great insight, especially, we all know that, HPC and AI and big data are all converging. AI, demands lots of computational power, and it is an HPC problem.
So I have a question. Can I ask a question right now? Or okay, my question is, so is IBM sort of incorporating this technology into their products?
You mean I talk about the Starlight. It's a software platform. So okay. I deploy it on the supercomputer center in my supercomputer center and applied the service to the.
Oh, sorry. Yeah, it's a. Okay, I'm sorry. I got to. Yeah. So I understand now, right? Yeah, I kind of misunderstood. I was thinking about IBM in my mind. So okay. So my question to you, sorry, my question to you is that how are you sort of deploying this?
I beg your pardon.
Now, how are you deploying your platform? I mean, is it sort of more in the research stages, or is it being deployed in real world?
Oh, yeah.
Yes.
You know, the Starlight, the softball, this, I call it a productive, but it's not a, you know, commercial productivity. It's, you know, it's a application platform. It's to provide the service with the supercomputer center, you know. We only deploy it on the supercomputer center now. And in Guangzhou, and we provide the service to more than 40,000 users come from different fields, such as the scientific research and the industry, and also the, you know, the government users. But this platform we have to maintain and to custom to some, you know, the users' requirements. Yeah, so this, and we also get the feedback and to improve the whole systems. And now we have deployed this software to different other supercomputer centers. I push it in the, posted it in my slides. You can see we already have this software used in Changsha Center, Tianjin Center, and Wuxi Center. So we will maybe, firstly, we have, you know, promote on the special domain application uses, because we have to custom some, help them user to custom, you know, the workload. So, and to custom the something like the application environments. But the low level platform support, that is could be used and deployed more, you know, more supercomputer centers and more clusters, yeah, something like that. Yeah.
Thank you.
We have, I think, another question in the chat from Mary. Mary, would you like to say your question?
This is exactly from my colleagues. Yuka Sasaki, could you say your question?
Hello, I hope you can hear me.
Yeah.
Yes.
Can you hear me? Okay, great. Mari posted my question here. I actually got to see the pre-recordings of your presentation, and I think I got to like go further into your presentation here. But so my question is, I'm actually currently in a hardware development field, so I'm not really doing research or anything about HPC. So this is like out of the blue thing. As a person in the hardware development field, we really get questions about how eco-friendly our products are. And like, I heard that you mentioned about the power cost performance balance in the beginning of your presentation. And I was wondering if like environmental friendliness sort of talks have merged around these like HPC fields. So this is just out of the blue question. If like there's any of these like designs that you incorporated includes any of the environmental aspects, do these projects have some like authority provided goals, such as like laws or governmental numbers described, or are they just like simple scientific challenges? So this is my question.
Thank you. Yeah, this I try to answer your question. You know, in HPC development, we also face many challenges. So you mentioned the hardware challenges. Yeah, it's a huge obstacles for the next generation supercomputer design. You know, we may have a larger and larger scale of the you know, the components, the CPU, the accelerator, and the system will be heterogeneous and in different levels. So the architecture design maybe become more friendly with the users. So, you know, we have a small core and a small memory capacity, and the heterogeneous in different levels, so the programming will be complexity. So we will also get many complaints from our HPC users because we want to pursue the high performance, even high performance in the nowadays supercomputer and the next generation supercomputer. And we also, when we design for systems, surely we will, you know, count on the materials, the CPU technologies, the whole systems, hardware, nowadays technologies, including the power consumption, controller, the technologies, something like that. But in our in my slide, we try to also in our work, we try to ease the the programming the burden and also the usage model. We try to provide a unified user model to the different application domain users. So we try to design user model and the workflow template to the domain applications and the users. So we will do some complexity and dirty work for our users. So we will try to establish a platform, a software platform, to separate, or we can call it to build a bridge between the end user, the domain scientists, with the complexity architecture. So that's what we are focused on. So I think it's always be the challenge. So I mentioned before, we always do the trade-off, but we try to give our users a unified and easy use environment. So that's, I think, I don't know whether I answer your question, but it's a dilemma about that thing. So we need co-design between the hardware and software designers. Yeah.
So yeah, I understand. Thank you.
Can we take one more question, Mary? Just trying to quick check on time.
Sure, sure.
Great. Yeah, we have another question from Chen Wang. Chen, would you like to say your question? It's also in the chat.
Yeah, sure. Thank you very much, Yutong, for your great talk. So I just have a very general question. So how it feels like to be a director of a national supercomputing center in China, and especially when most of the professionals in this field are men. And what are the major challenges you face to lead a big team, as well as being a top researcher and also a good wife and mom?
Thank you for your question. Yeah, I'll always be asked for such kind of question, but in my honor, in honest, I seldom think about the women or men, to play the different role in the work. I don't think so, because maybe it's I think become the director of the supercomputer center is based on my maybe more than 20 years hard working in this HPC field. So I don't think about more about the women or men, the role about that, the different about that. I think there's women have our own advantage in many aspects of our worker, and maybe we have some disadvantage, but I don't think it's I think the difference is not from the men or women, from the gender. It's come from the person. Every person are different. So I don't think that's some make me more difficult about that in my career. I think in China, I don't know, maybe it's not, could be take a sample for everyone, but for me, I think it's this general work. It's my career, just like everyone or other people to choose another career. Because I have my journey, because HPC journey from my, in the university, and after university, I will stay in I joined the HPC team in China. So I think I'm lucky. So they're always in a relative higher platform or starting of my career, because I have a very, perfect and powerful teams. So we work together and we achieve different goals, and to the even to the top one of the supercomputer. So I think I'm lucky. And talk about how to balance the research and the work and the family. I think it's always a question. So I don't think that they have a balance. So you should join work and life. And I think it's a very important thing for myself is you should to get the support from your family, from your husband, from your son or children, and also from your parents, something like that, and a friend. I think it's maybe, I don't know. Yeah, thank you.
Yeah, thank you so much for your modesty. You contribute to everything to Lucky, but indeed you did a fantastic work. Thank you.
Thank you. You're welcome.
Any more questions from the audience? We've also prepared a set of questions. Maybe I'll just ask one of them, given the time we have. So what do you see as the future of accelerators in computing after the GPUs? We would love to get your view on that.
Yeah, we talk about accelerator. I mentioned in my talk. I think the heterogeneous architecture is the main trend for even for the next generation. Maybe exascale or 10 exascale systems. So after GPU, we will think we need not only we think about the GPU architecture, we think the powerful processors, what we need for the next generation supercomputer. And we also have the contain or the control of the Moore's law. So we will think about the power consumption. I think it's a key point for the next generation architecture, especially the CPU or the processor accelerator. We need to control the power consumption, because I think we also need to we should get a processor. We have power, high performance, and also the high bandwidth of memory bandwidth. So now, in some successful, even for the GPU A100, something like that, I don't think this only successful because of this high computing performance, but also it's a high memory bandwidth. So many applications, different kind of applications need to the data movement and data processor. So the performance is important, but the data management or data processing performance is also important, or maybe more important, we need to consider in the next generation of supercomputer. So maybe the next generation, we have the processor. If we think about that, it's combine the CPU and the GPU in one chip. So it's maybe the mixed precision we need to take some advantage of the mixed precision architecture design. So we can, we can shift different model, different precision in one chips in one software environment, because now we need to set the 64 bit and all the 16 bit and for the software. But I think in the future we may could control and combine the different and mixed precision in one architecture and one compiler system and one application environment. So we need to balance the computing, the memory, the I/O, and also the mixed precision together to get the to control the power consumption. So this design, I think, is a very, very large, the die size of chips, but we need to tackle the architecture problem in the future architecture.
Yeah, thank you. That's a great answer. Definitely, balancing all of these different elements will be important. So I think, Lorraine, maybe we can move to the next speaker.
Yes. So the next speaker is Bhavani, and the session chair is Mare. So we'll turn it over to you, ladies.
And thank you so much, Professor Yutong, for your great talk and all the wonderful answers.
Thank you.
Hello, everyone. Can you hear me?
Yes.
Yes.
All right. And can you see my screen now?
Yes.
Okay. Let's get started. Hello, everyone. Thank you very much for joining IEEE Women in Services Computing Symposium Keynote Speech 2. My name is Maria Abe, a session chair. I'm working as a senior software engineer at IBM and also program chair of Women in Services Computing. Before starting the session, if you have any questions, please post in Zoom UI if you see at your Zoom. Okay, the speaker is Dr. Bhavani Trasingham. She is elected fellow of ACM IEEE NAI, reflecting the depth and breadth of her contribution to computing, engineering, technology, innovation, science, and mathematics. Okay, here's a brief biography of Bhavani. She's a founder chair, professor of computer science, and executive director of the Cybersecurity Research and Education Institute at University of Texas at Dallas. Her research interests are in integrating cybersecurity and artificial intelligence or data science for past 35 years. She has received several awards, including IEEE CS 1997 Technical Achievement Award, ACM SSC 2010 Outstanding Contribution Award, and many other awards she achieved. She co-chaired the Women in Cybersecurity Conference in 2016, and also delivered several keynote or featured addresses, including at the 2018 Women in Data Science at Stanford University, CyberW, iMentor, SWE, this is very famous community of women, and WITI and WICE. She received Women in Technology Award from Dallas Business Journal in 2017, and is the recipient of the IEEE Cybersecurity and Class 2021 Special Recognition Award for her tireless work on promoting diversity, equity, and inclusion among women and underrepresented minority communities. Okay, here is a summary of the first half of her talk. The title of her talk is Integrating Cybersecurity and Data Science for Cloud-Based Information Sharing Services. Her talk is subdivided in the three parts. Firstly, she introduced integrating cybersecurity and AI/ML data science. Secondly, she introduced examples secure cyber physical system and security for Internet of Transportation system. Thirdly, she introduced application of AI/ML data science for smart Internet of Transportation systems. I think the challenge includes how to manage various kinds of data from devices for transportation systems security, including autonomous vehicles. So now let me share her video. I clipped especially the privacy-aware, policy-based quantified self-data management framework.
So Maria, I've got the presentation. I can give it right now. I've summarized it.
Okay, can we share your slide?
Yeah. So I summarized it into. Oh, it says I cannot share my screen. So you have to, because I have. Okay, now I think I can share it.
Thank you.
Yeah. So what I did was, okay, so I have selected some of the charts to present actually both parts. And I think that might also answer some questions. Just a second, I want to just go back to the beginning. That might, so I have like a 30 chart presentation. So I cut it back to less than a third. So I can, why is it going, I'm sorry, why is it going down? Okay, maybe that's the problem. Okay, great. Okay, so I have two parts to my presentation. One is a technical part and the other one is sort of the importance of mentoring. And I want to talk a little bit about mentoring also, a couple of charts, because there was a question earlier for the previous speaker, how you can, how women can sort of succeed, right, in their careers. And so I'll talk a little bit about that as well. But I'm going to focus mainly on the first part, which is integrating cybersecurity, AI, ML data science with applications in Internet of Transportation system. So again, the presentation provides all the details, right? So Dr. Abe showed some of the summary, right, the different parts. So I'm going to just talk about some of the key points. The one point I'm making is the privacy-aware, policy-based. So again, there is so much of data that's being collected. And there is this movement called quantified self, where data is being collected about various people to benefit the people, like healthcare. So for instance, when I go and open my refrigerator, say, and I really like milk chocolates and vanilla ice cream, right? So once a week, that's how I go and buy vanilla ice cream and treat myself. But I don't leave anything in the refrigerator because I'll, finish everything in one day. So it'll be really great if the system can give me the microprocessor, or my iPhone can tell me, look, you shouldn't be eating, right, milk chocolates and vanilla ice cream. So that's the quantified self movement that sociologists and psychologists are working on. But imagine the amount of the privacy that could get violated, because I wouldn't want my insurance companies to know that I'm eating, drinking vanilla ice cream and eating milk chocolates. That's going to be really bad. And so that is where we come up with we designed and develop a system. That's what I show here, that does data collection in our iPhones, data storage, data analytics, and data sharing. But so there's a lot of data, health related, fitness data, location, social media, image, video. So the important thing is policies have to govern, okay, every aspect. So collecting data, right? Policies have to say, can you collect this data? Can you not collect this data? So when you collect the data, you've got to tell them what you are going to do with the data, the usage of the data. So you need to have policies. storing the data. What data do you store? What data you throw away? Again, policies have to guide. Analytics, analyzing the data. That's really the concern, because you can analyze, and from lots of public data, you can infer or deduce highly private data, right? So for instance, another instance is that you don't want to divulge your private data. So suppose, say, I have COVID-19 or I had COVID-19, you may not want to tell people, but it might be good to analyze the various areas and say people who live in this particular zip code in Dallas-Fort Worth have a higher predisposition for COVID-19 or for AIDS or whatever, right? So you want to, so there again, policies have to govern, right? Or govern what sort of analysis you can carry out. And then again, data sharing, again, it depends on the policies, right? The policies, so it's not sort of TOY policies where John will tell Mary, I will tell you a secret, but don't tell the secret to Jane, right? But the policies are more complex. So we did a lot of work earlier on information sharing, but we used what I said, we are computer scientists. So we are not policy folks. We came up with some TOY policies, but now we are working with real policy experts. And so to understand policy, more recently, I also got a certificate in public policy analysis from the London School of Economics. And so now I have a much better understanding, I hope, of policy. In fact, that came to help me in one of the proposals I'm working on. It's due tomorrow. So I use some of that stuff in the proposal. So again, policies have to govern whatever we are doing. And it cannot be toy policies. These policies have to be from policy experts. So we are working with the policy experts. So that's one aspect, right? Because of this big data problem. Another thing is data science, machine learning, AI for cybersecurity. Now, this sort of work has been going on, not yesterday or today, but in the 1990s, actually 1995, when data mining was becoming sort of a big thing. We started applying for cybersecurity, for intrusion detection, insider threat detection, and so on. So again, we use past data to build classification models, predict the label of future instances, right? And then it helps the decision making. So we train and we test. So you can ask, what's the big challenge today? This problem has been going on. I mean, the solutions have been developed for 20 years. The challenge is that now we can do real-time data analytics. Right. So again, how do I, in my talk, I tie it to services, because these technologies can be real-time data analytics or even data sharing or whatever can be offered as services. So that is really the progress that we have made. And another thing is big data. So when we talk about big data, data is coming in streams, lots and lots of data, continuous data, very common in our connected world, massive amounts of data. So streaming data is coming. So and the concepts are changing, right? What do we mean by that? Today, the system will say buy Microsoft stock. Tomorrow, it's going to be IBM. The next day, it's going to be Google or Apple or Amazon or Facebook. So it's constantly changing. While in the old days, it's just one model, right? So what we do is we build an ensemble collection of models, and then you can't keep the models forever. The bad models are being thrown away, and the good models are being kept, right? So the outdated, not bad means outdated models are thrown away. And so when the testing comes, the models are talking to each other and deciding which ones to throw away. And so attack traffic with block and quarantine, benign traffic, it goes into some sort of server. So this was joint research funded by NASA, and it was joint work with Urbana-Champaign, J.W. Hahn. But I also want to mention that in stream analytics, one of the top researchers is at IBM, TJ Watson, and we've written some joint papers with him, Dr. Charu Agrawal. And those of you all at IBM may know him. He's really well known and really brilliant when it comes to this area. So my colleague Latifa Khan and Charu Agrawal have got a number of papers. I have a few papers. So IBM is leading in this area as well. Okay, so where did we apply? We applied this to a number of problems, right? Insider threat, intrusion detection, and so on. So here is an example for insider threat where, we use both supervised learning and unsupervised learning. Supervised is support vector machine. Unsupervised, we use graph-based anomaly detection techniques. So what is inside a thread? Bad people are pretending to be good people in the system, carrying out espionage. Similarly, malicious processes, they could look like benign processes, but actually inside they are really bad. Okay, so so we have lots of typing and various system calls, and then you look for sort of unusual patterns, build a dictionary. So that's what our GBAD algorithm is doing. And then of course, again, the uniqueness, we apply ensemble of models, right? So gather data from iChunks, we build an ensemble of models, extract features, apply learning. So that's sort of what we are doing. And then when it comes to testing, we test against the models. So again, when the models are outdated, we throw away the models. And again, very limited human in the loop. We have an algorithm, ensemble update algorithm. When it's outdated, we throw that model away. Okay, so that's the idea here. Now, another area I want to talk about is this. This is one of the most, it's becoming actually very, very, I don't want to use the word hot because hot means buzzwords, right? Very important, critical area. What is happening here is adversarial machine learning. The machine learning AI techniques could be attacked. We are using AI and machine learning and data mining, data science for almost everything now. What happens if those machine learning techniques are attacked? Then you cannot rely on the results, right? So if it says by, say, Facebook, it might just give you wrong information purposely, because adversary, and this is not just for, buying stocks or something. If you are working on, let's say, the vaccines for COVID-19, it's so competitive, right? Because billions and billions of dollars are to be made. And so pharmaceutical company X could sort of look into, invade into the systems of pharmaceutical company Y, and X could thwart the data, corrupt the data, corrupt the models, and the vaccines that are produced by Y may be of no use. So it's really not depending on this. And so adversary modifies the data to defeat the learning algorithms. So we need to understand how the adversary is working. It's not concept drift online. Adversary avoids trying to be detected, right? Avoid being detected. It could happen during training, poisoning. So we've done a lot of work in this area. It sort of becomes a game playing because you have to try and defeat the adversary. So adversary tries to defeat you, you try to defeat the adversary, it becomes game playing. So look what happens. The blue circles are good instances, the red squares are bad. This is the support vector machine boundary. And what the adversary is trying to do, learn what we are doing and trying to push the bad instances into the good instances. And so we will not catch 1, 2, 3, 4, 5 bad instances would not be caught. Okay, so we are going to now have false negatives. It's not good to have false negatives or false positives. And so the same thing here. Let's say this is the support vector machine boundary line. The red crosses are the bad instances, green circles are good instances. The dotted line or dashed line is the support vector machine boundary line. And the blue line, as a result of applying game theory, try to model the adversary behavior and so on, we are pushing the boundary line to here. And when we do that, some of the bad instances are being caught. All of these red crosses would not have been caught earlier, but now we are catching them because we have moved this line. And essentially that's what happens here. All of these things in between, which are bad, are being caught, which would not have been caught. So you can ask the question, why not move this right here, the blue line? That means all the bad instances could be caught. If we move the line right here, then all these good instances also will come out as bad instances. So we are going to get a lot of false positives as well. So that's where the challenge for us to where to draw the boundary, right? So the threat model, attacker modifies X to X prime. You can modify the packet length and add good words to spam and noise to an image. So this is a very, very critical area now because of all the attacks to machine learning. Okay, so that's this one part, right? Integrating cybersecurity and data science /AI. Now, the second is a completely different topic. The third part is how do we apply 1 to 2? Okay, so the second part is Internet of Things or Internet of Transportation. Like we know Internet of Things is your refrigerator connected to your television, connected to your camera. Whenever I look at the camera, I get worried. Who can attack the camera, right? If the camera is attacked, everything that I'm doing in this room will be caught. So I always try to put the cover, but sometimes I forget. But anyway, so everything is connected. Similarly, your cars are connected to your trucks, connected to your trains and roadworks, and which is really a great thing because a lot of sensor data being shared and distributed. And so we can avoid accidents and so many good things can happen, right? But the challenge is that these Internet of Transportation things could be attacked. Imagine if all your signals are attacked and spoofed, it could be disastrous. And this is really very real that could happen. And so we developed, and my presentation goes into detail, developed something called physics-based anomaly detection. It's a fairly simple, you might ask, so what's the big deal? And I'll tell you what the big deal is. So the algorithm has, so we take all the physical properties and we build a reference monitor. Reference monitor is essentially, in security terminology, the security critical component. So algorithm, where we build a model, that's the challenge, building the model. Why is that a challenge? Because you need really a control systems person who really understands. Computer scientists can't build, it's a physical model. So it has a lot of differential equations that you will have to solve. So capture the physical properties. And then we build an online tool. So we use extended Kalman filter, and we raise an alarm if there is a problem. So it's a very simple algorithm, at least for now. But the model offline, right, that's really the challenge right now. So we develop the system, and I won't go into the details. I talk in the presentation, more details of the algorithm. But our online algorithm is based on extended Kalman filter, but we tested it for drones and also for cars, not for sea vehicle, right? And so we looked at different attacks, and there's an overhead, and then we had 0.2 seconds, and the other was 0.1 seconds. So each threshold produces false alarms 2%. And so it's 2% is still high. We need to bring it down, and that's where we are looking at machine learning. So this is my part 2. Part 3, as Marie was saying, applying AI and machine learning to Internet of Transportation. So my presentation talks about part 3, and that's what we are working on right now. So there's a lot of questions we have because we just started that particular research. But one thing I want to tell you though, in that part 3 is this particular thing. Remember privacy, we are policy based with our cell phone for quantified self, right? But now we are in a car, it's all about cars. And instead of healthcare, social media data, what we are planning to look at is the radar, the GPS, the cameras, the LIDAR, ultrasonic sensors, and that's the data being collected. And what we are saying is policies have to govern how to collect data, how to share data between cars, how to store the data, and so on. So this is what we are beginning to look at. And then we are also looking at how machine learning, instead of applying Kalman filter, how machine learning can be used to detect the attacks to transportation systems. And the third part is adversarial machine learning, right? Could be even exacerbated because we do have machine learning. Everybody is using machine learning now for autonomous vehicles because it's so useful, right? But if those machine learning techniques are attacked, then it will be disaster. So many accidents could happen. So that's really what we are focusing on in part 3. So that's my technical presentation. My second part, I'm talking about mentoring. I know there was a question earlier. And why is mentoring so important, right? For diversity, equity, inclusion, for women, underrepresented minorities. And so what I'm trying, the key point I'm trying to make is that there are many opportunities for us in services, in cybersecurity, in artificial intelligence, and so on, cloud, edge computing. But why there are numerous opportunities? See, I've had a 41-year career, so I've been around for a long time. So I believe that, and also my career, I'm originally a Tamil from Sri Lanka, and I got married when I was 20, moved to England in my graduate work for my master's and PhD for 5 years. And then I moved to the US in 1980. So my career has been in the US. So it's almost impossible, I find, for a person to succeed without the advice and mentorship of senior researchers, developers, technologies, right? And it's almost like every person I've known who has succeeded has someone who has guided him or her. So every career professional must have a mentor. So that's what I'm stressing, right? And so again, why do women and minority communities, and I'm looking at United States, I know the keynote speaker was talking more from China. So lack of mentorship is probably one of the most important reasons, because lack of opportunity start at an early age, because we know that boys are given preferences over girls. Almost every culture, although I'm saying that in the Western cultures, it seems to be even more so than in the Eastern cultures. So the women mainly work to supplement husbands' incomes. Minority communities have a tremendous disadvantage because they are really starting from behind. And so if the women and minority communities are fortunate to get an education, there are very few from these communities at higher positions, right? So if a woman is sort of starting as a developer, software developer, there are so few women in director positions and so on. But right now, IBM seems to be doing so well, right? We have so many directors, and Lorraine is doing so well, and the others as well. But still it's a challenge, right? So the thing I say is that so in the academic field, right, a lot of the department heads, deans, and so on are men. So from a department head to go to dean, if you have 10 department heads competing, and if 9 of them are men and 1 is a woman, then of course the job is good. Not of course, very likely the job will be going to a man, right? So we need more women to motivate them to get into management positions. So my last chart here is what steps should be done, right? First step is to realize there's a problem, right? So people often, those in the non-minority communities, do not realize. And there are affirmative action programs, they have been around, but again, that's the people say, oh, she's in that position because she's a woman, right? But more recently, I think the Black Lives Matter, Me Too movement, I think things are changing. And a lot more emphasis on diversity, equity, and inclusion. That doesn't mean you give the job to a woman or a minority community person. You want to include more qualified people, right? So as I said, for the 10 positions who are 10 candidates who are going for a dean, if 5 are men and 5 are women, then the chances of women getting the position is higher. Whereas if 9 are men and 1 is a woman, then the chances are much less. So we want to increase the pool. That doesn't mean that we just bring anyone. We need qualified women. So that is the challenge we are faced with, right? So these are not just words. If we can all work together. And then I'm also talking, diversity is more of a domestic sort of United States, in the sense that African Americans, Hispanic Americans, LGBTQ. So I'm sort of chairing the diversity committee for IEEE ICDM. Sorry, ICDE is an international community. But what I'm saying from an international community point of view, African Americans and Hispanic Americans and LGBTQ and so on, they may not mean much. But one thing that ties the whole world together, brings the whole world together, is women, because every community has women, right? About 50% men, 50% women, and we want equality and equal opportunities. So we have to all go beyond our own gender, race, ethnicity, and try and help everyone to succeed. So that's sort of my presentation. As I said, I summarized everything and put them into, selected some key charts to present. And so I think I'll stop sharing, and then if there are questions, I'll be happy to answer. So, yeah.
Thank you very much, Bhavani. And I'm sorry, we don't have enough time to show all of your chart. Let me pick up one question from the audience. It is from Faliha. Let me read out. It is always difficult to find good mentors. I feel I agree with her. And any idea from where to start?
Okay, that is, if you look at my presentation, after I talk about this, I go on to talk about my personal story. Okay, that happened 25 years, 26 years ago. Actually 27 years ago, because I did not have a mentor. So this was when I was not at academia, when I was with the Federal Research Lab, before I joined academia. So I was really good in my work. I mean, I had more publications and more, I was having patents, and then I was in a lot of projects. I was bringing in funding, but still people couldn't see me, right? Because being a woman and also being a woman of color, I would say. So they couldn't really, I mean, they would always say, criticize and say things like, oh, Bhavani is a loner. Bhavani is, maybe she's not that good technically, even though my credentials were so much better than everyone. So because there was a position that was becoming, they were vacant. And so I really wanted the position, and someone else also wanted the position, but they were sort of saying negative things. And I didn't really have a mentor at that time. Fortunately for me, there was a lady who was only like 3 years older to me. She was senior to me, that one position higher. And she and I had worked together on a project, and she really liked me. Okay, she's a Caucasian lady. And so she really liked me, and she knew what my capabilities were. And when she started hearing these stories, she really put a stop to it. And she talked to my boss and said, you have to support Bhavani in this. She's very good. And that is when I began to sort of realize that you need a mentor. And so this lady, she was leaving the company, and it was her position that was becoming vacant. So she told my boss, a very good man, because he was getting puzzled when the other side was saying all these negative things about me. And so she made him promise that he will mentor me. And so from then onwards, I've always found a mentor, right? Even now, I've had like 40-year career, 41. But it doesn't mean that okay, so the mentor doesn't have to be really an older person, right? There's another lady I talked to. She's much younger to me, but she's in a very senior position in another university. I talk to her and get advice. So I think you need to really try. It's hard to find mentor, but after 1994 fall, that was 27 years ago, I was able to get this mentor, and he was able to help me. And once you get a little bit of momentum, then it becomes less, I won't say easier, less difficult. Do you see what I mean? So we have to make an effort. That's what I'm saying. So I didn't know about it before. I thought, okay, you do good work and you will be rewarded, but that doesn't happen. And men have mentors in the sense that there are more men, right? The more numbers, whether it be Caucasian men or East Asian men or South Asian men, the numbers are more, especially in computer science. So they support each other.
Thank you.
Anyway, yeah.
Thank you, Bhavani. I'd like to thank Dr. Bhavani, and I strongly recommended to watch Bhavani's video. It's very motivating.
Thank you very much.
Yeah, this session is now closed, and I'd like to pass to Chen Wen, the next session.
Okay, so I've stopped sharing, right? So I'm okay, right? Thank you.
Thank you very much.
Yeah.
Thank you. I'm going to share. Okay, could you see my screen with the slides?
Yes, we can see.
Yes,
okay.
Right.
Okay, great. So hi, everyone. I'm Chen Wang from IBM Research, and thank you very much for staying with us to the third talk. So I'm very excited to introduce our next keynote speaker, Maya Vukovic, and our guest speaker, Fumiko Sato, who will help answer questions and summarize the talk. So Maya is undoubtedly a successful role model for women in service computing, and a great technical leader in IBM Research. She is elected as an IBM Fellow in the class of this year, 2021. She pioneered the use of AI in service management, with the research and technical strategy for AI-driven application modernization, and the movement of enterprise mission-critical application workloads of hybrid multi-cloud platforms. So internally, as an IBM Fellow, Maya advanced IBM's cloud leadership in AI-based tools for enterprise application modernization, data modernization, and application replatforming. She is responsible for producing and implementing a winning strategy for enterprise applications modernization and expanding that scope to make OpenShift the target platform for modernized applications. So Maya is also a member of IBM Academy of Technology and an IBM Master Inventor with over 155 patents granted. She is an IEEE senior member and was awarded Women in Service Computing Award by IEEE. So she is a great leader in this community. She's also strongly advocating for women in science and technology. So here is a favorite quote I have from her when I read an article introducing her. So she said, teaching and mentoring others is very important to her, in particular, advocating for women in science because innovation is the creative ability of all people. Diversity and inclusiveness are key to generating more innovative solutions to problems. So, but unfortunately, due to a flight conflict, Maya cannot attend this live Q&A session today. So she sent our guest speaker, Fumiko Sato, who is her good friend and great co-worker on the project of AI of Code. So Fumiko is a senior technical staff member in IBM Research and also a senior manager of hybrid cloud and security IBM Research at Tokyo. So she leads the research in security and automating for enhancing hybrid cloud platform. Fumiko, could you step in to introduce yourself more?
Yeah, thank you very much for introduction. So hi everyone, my name is Fumiko Sato. As already introduced, I'm reading hybrid cloud and security research in IBM Research. Also, we are collaborating with Maya's team. And of course, Maya is a global leader of the work for application management with AI. So this is a big team, big global team. So involving from United States and Tokyo and India and some others. And so then I'm collaborating with Maya and other team members. And so then, yeah, actually today I like to summarize the Maya's talk as much as I can. And also then I like to share our idea and some advice on your questions. Okay. Yeah, please go ahead. Is it okay to go to the summary?
Yeah, do you want me to share or you want to share some of the slides?
But anyway, how much time do I have?
6 minutes.
Mary?
We have 6 minutes.
Okay. So I have shared my screen. Yeah, I hope you can see my screen. So this is the chart Maya presented in the video. So then she mentioned about our work related to the application modernization leveraging by AI. And so then, first of all, she presented the level of AI. And so then now I believe that we are in the middle of broad AI, which is the multi-task and multi-domain AI. So then we are trying to apply this capability of AI to the accelerating the transformation to the cloud from a legacy application and a legacy system. So you can see we have several steps and to modernize application, the legacy application. So then we are trying to apply these phases to support software engineers and architect, right? So then I will skip this one. So then the challenges to support application modernization, we face several technical challenges. So then actually the AI has need a lot of data, but then in the research of application modernization, there's not so much data. We have only limited data. It is one big challenge for technical challenge. So also that we need to support refactoring from legacy application, because this is a very depending on the human task, and it's very manual task. So then this is a good area to support AI. So that this is a challenge we are focusing on. And so IBM Research has developing some tools to support some engineers. So that one is application containerization advisor, which is AI-based advisory, to start the modernization process. So then, and these tools provides some direction, some initial direction of application modernizing application. And also, we have several other tools, Mono2Micro, which is supporting refactoring based on the runtime analysis. The runtime means we need to collect some application running data, running logs, and then we can analyze the logs to find which part of the application should be packed as one microservices. And so you can try this kind of tools from IBM site. And also another tool is Candidate Microservice Advisor, which is static analysis-based advisor for modernization. So you can see this tool will show relationship between the application inside application class or something, and then which recommends the potential microservices cluster from one big monolith application. So this is the work that the Maya's team and our team is working for. And also now we are moving to open source community. And you can see this is a chart. So I wish to share the website. This is a Conveyor community, which is collaborative community with led by IBM and Red Hat. So it accelerates, it provides some acceleration tools to support transformation to the Kubernetes platform. So please check it, and you can see some of the projects like this. So we have several projects to support a transformation to the Kubernetes. And so Maya's presentation, this one, and also another key tool is so you can see the Coronet here. So IBM announced the project Coronet this year. So Maya is one of the leader of this project. And so then she mentioned that the one of the key tools is data, to accelerate the research of the AI related, AI for code research. So then we created the program repository to accelerate the AI for code research. So you can, this is open source, so then you can access this information from IBM website. So that please join this open source community and check this capability, and please join the research on top of this repository. Yeah, that's a summary of the Maya's presentation. So this is
thank you so much, Fumiko, for the summary. I just want to check with Mary. How many questions can we take?
One is good. It's time to move to the next session. Sorry about that.
Yeah. Okay.
Okay. Sorry, Fumiko. So I have a question from Mary. So if we think of mission critical services, how does the modernized microservice architecture save the runtime performance like latency and throughput?
Yeah. That's a big problem. So that actually, in our current phases, we are trying to find the actual implementation of a legacy application. So that actually, this is a so big application like financial services or some the backend services of the big company systems. So the first of all, we need to reveal of the actual architecture. Based on that analysis, we can, how can I say that, separate one of the mission critical parts and one of the how can I say, the part we can open other web services or something. So that's a point we are focusing on. So that we need the one of the key technology is how we can separate the important part and not the open part accurately. So that's why we are trying to several techniques based on the static analysis or runtime analysis, and also the mono to micro is one of the approach combining the both technology. So yeah, that's a big challenge. Yeah.
Thank you very much. Your answer is very reasonable. Thank you.
Thank you.
Thank you again, Fumiko, for your talk.
Okay. Thank you very much.
I think that's the end of the third talk. Mary, I'm handing this back to you.
Yes, thank you very much for all of the participants. And now it is time to move to the session 2 WISC. This is a different link. So I want to pass it to Lorraine to closing remark for session 1.
Oh, we are going to close this session. You're right, Mari. Okay, thank you everyone, especially to the speakers and to the session moderators. Thanks for a great job. I think you did a lot in a short period of time. Hopefully next time we'll be in person and we can give the talks in their full length. So let's move to the next session, right, Mari? And we have to actually go and click on the other link, session 2, because it's a different key room for that one. Okay.
Yes, once you go back to underline.io platform, you can see join session for WISC 2. Please access and see you soon.